What's up, my mathletes? That's right, Mr. Muscarella coming at you. And in this video, we are going to learn how to apply the double angle formulas. So let's go ahead and review a little bit, actually, something we learned last class with the sum and difference formulas. So what I want you to do is pause the video in a moment, but the u and the v are going to be both the same in this case, because we're going to take sine of 2x, and we're going to split that up, right? Because we know x plus x, we know that that's 2x, right? So we're going to take the sine of 2x, and we're going to split it up into a sum formula. So what I want you to do is go ahead and apply that and see what you learn. All right, so go ahead, pause the video, and then let's come back and see how you did. All right, so how'd you do with this one? Now, what I want you to do is pay attention to the order here, right? Because we have sine times cosine. And remember, just like addition, the multiplication property it can be commutative. So sine times cos is the same thing as cos times sine. So even though when we initially write the formula, we've got, cosine, but then you can multiply or change the order that you're multiplying. So you can put the sine first and the cos second. And then that way you have two like terms, bro. When you add two like terms together, you get two of those. So 2 sine x cosine x is another way of writing sine of 2x. So see, that's what's going to lead into these guys here, our double angle formulas. So sine of 2 theta is the same thing as 2 sine theta cos theta. And again, thetas could be A's, B's, alphas, betas. They could just be X's. It depends on the textbook, the publisher, your teacher, all the things you can't control. But these are formulas here, so we're going to go ahead and apply them. We're going to do a couple different examples, just two. So here we go. Let's take a look at this very first one. So we're told tangent of theta is 4/3, and we're also told that that angle is between 180 and 270. So this is two clues, right? So we got two clues. So we have two clues here. One of our clues says that tangent is positive. The other one says it's drawn in, or that our triangle's in quadrant number 3. So the very first thing that you're going to want to do, of course, is draw your right triangle, bro. So draw the triangle. Theta goes right here in that angle that is closest to the origin. Now from here, tangent is 4/3. So tangent, remember, a couple different ways you could remember that. It's opposite over adjacent, or you could do that same thing. If you think about x, y, and r going around the unit circle, you could have y over x. So either way you want to think about it is okay, but in either case, the opposite would be 4 and the adjacent would be 3. But wait a second, man. This is in quadrant number 3. My values can't be 3 and 4 in quadrant number 3. That's correct. So even though tangent is positive, we have to remember to add a negative sign to each one of those. Because if you took the ratio of -4 divided by -3, right, that ratio, because you have two negatives, you would still end up with a positive value there. So don't forget, this is where you have to be really careful to make sure that you add in a negative sign. Now there's two different ways you can do this. Find the missing piece. So here we're going to call this r, because that's the radius of our triangle that's around the unit circle, or you could also call it c, but we're going to call it r in this case. So we're going to have x squared plus y squared equals r squared. So first thing you do is draw the triangle, fill in the missing pieces. The next thing you do is you're going to use Pythagorean theorem to find the missing part, the missing piece. So in this case, we have -3 squared plus -4 squared equals r squared. All right, and then from here, we have 9 plus 16 equals r squared. We get 25 for the value of r squared. So plus or minus the square root of 25 for the value of r. And in this case, because we're finding the radius, then we would know that that is going to be +5 for the value of r. So r has a value of +5, all right? So that's the first thing you do after you draw your triangle, is you say, okay, let's go ahead and use Pythagorean theorem to find the missing piece, the missing side. All right, so that's it. Let me make that a little bit smaller. So quiz time, right? So first thing, if this were a quiz, right, you'd get a check for finding the, drawing the picture correctly with the correct values. Get the, showing your work to find the correct value of missing r. Now, some people might recognize this as a Pythagorean triple. Cool. If that's you, you do you, boo. Now we're going to go ahead and take a look at sine of 2 theta. So sine of 2 theta is the formula. So again, these are all our different formulas that we'll have to apply here. The values for sine and cosine are going to come from the triangle that we just drew. So here, when I take a look at this, sine of 2 theta. So when you do this, you'll write it like this. You'll write sine 2 theta equals 2 sine theta cos theta. So just get in the habit of writing the formula down first, because that way it helps you kind of get it memorized. Now from here, our value of sine, so I have to look at my triangle right here, and sine is opposite over hypotenuse, or y over x. And so that would be -4 over 5. So -4 over 5 for the value of sine. Now cosine is x over r, or -3 over 5, or I could also say adjacent over hypotenuse. So all these things tying in here together. When you do your multiplying, again, be super careful when you do that, because you have two negatives there. When you multiply them together, -4 times -3 times a 2, we end up with a value of 24. So we get 24 in the numerator, and the denominator is just 25. So that's it. So the value of sine of 2 theta for these conditions is 24 over 25. That's our ratio there. Now let's go ahead and take a look at cosine in the next video.